Good morning. We are at the end of our course learning vehicle crashworthiness, lecture number 27. And today we are going to look at the concluding module of our course, module number 7, Introduction to Dummies. So the title says Introduction to Dummies. We have been seeing this dummies in our lectures right from very first class. So we are very much familiar with this. What is this dummy called? The dummy is nothing but it is a mechanical. Surrogates represent a human biofidelity characteristics, and it's also called otherwise anthropomorphic test devices, which are going to have complete required instrumentation at all important parts of the human body. And they would be placed nicely in your vehicle crash testing time, and the data is measured during the crash test executed by these dummies, and their kinematics are the basis for stating the evaluation of the safety aspects of your vehicle, whether it's happened to be a passive safety system or active safety system and so on. So that is that important role these dummies do play in our subject vehicle crashworthiness of automobiles, right? So with that understanding, we are just going to look at a kind of review or an overview or an introduction how this dummy family has been evolved right from its first born, that's called the Sierra Sam dummy in the year 1949 in the Sierra Engineering Corporation. The first dummy was introduced or created, and that the dummy was created for the purpose of doing numerous number of seat ejection tests in aircrafts and automotive industry as well. So that is what is its history. The ancestor or the grandfather of any dummies that you look at it in a vehicle today is who is nothing but Sierra Sam ATD. So we are going to see from there and how the dummies are today developed and their population, and then their utility by many of the vehicle safety regulatory authorities. They do keep them in the crash test, and then the purpose is met. So this is what is the background of dummies that we know in every lecture, from the first lecture till today's lecture. We had a dummy role in our lecture, at least a minute. So we have been seeing them, and this is at the dedicated lecture for dummies alone, and that is going to nicely end the learning and orienting the all aspects of vehicle crashworthiness as per the syllabus content in our mind. This is the kind of field that's upcoming in our Indian context. But in global scenario, the vehicle crash test and safety development, if you look at especially in European and in Western countries, US and other Asian countries, you see that they got a matured status, and we are also no way inferior to compete and to have such kind of authority, and that's what we have been witnessing. And there's a group in our class that's working on the safety program of our own country. So it's all nice that we were doing, justifying learning this course. And with that note, let me quickly share my screen and then go ahead with the lecture. It's a kind of fast quick through and then ending by exactly by 8 o'clock, right? So let's just go through the lecture. So you're able to see this lecture slide, and it is module 7, Introduction to Dummies. And look at here, the anthropometric dummies, they are called. So dummies are ATDs, anthropomorphic test devices, commonly referred to as dummies, or mechanical surrogates of humans. Crashworthiness engineers use ATDs to evaluate the occupant protection potential of various types of restraint systems in simulated collisions of new vehicle design. Current ATDs are designed to be biofidelic, Biophilia means what? Meaning that they mimic pertinent human physical characteristics such as size, shape, mass, stiffness, and energy absorbing and dissipating characteristics of a human. The dummy's mechanical responses simulate corresponding human responses of trajectory, velocity, acceleration, deformation, and articulation when the dummies are exposed to prescribed simulated collision conditions. Engineers equip dummies with transducers, those are instruments like they use to measure acceleration, deformation, and loading of various body parts. Analysis of these measurements are used to assess the efficacy of restraint system design. So that is the background, and that's why these mechanical surrogates dummies called anthropomorphic test devices. You could see that these dummies are ATDs and they are mounted with various transducers that we have seen in these locations. You see, importantly, at the CG of head, you have an accelerometer, and then you have neck force and moment sensors here, and then sternum deformation sensor here, and the ribs, and thorax CG accelerometer at the mid of thorax. So this all sensors placement you have very well now able to find as we spend a lot of time on learning biomechanics aspects of human anatomy and injury severity levels and how what are the levels or the values in particular the deformation of thorax for that matter, what is the rib displacements permissionable, all dictated by different regulatory authorities, all we have seen. So this slide would be very easy for you to follow. So pelvis location CG accelerometers and femur force sensors, knee slider sensor and upper tibia sensor. This is what is called tibia and lower tibia sensors and so on. So these are all because instrumented with transducer. These dummies are called ATDs. And the picture here is interesting. It is a finite element model picture. So one side we have a dummy development, and the other side we have a computational facility, mathematical advantage. And they can replicate the dummies what are doing a real-time crash simulation test can be replicated on virtual environment using finite element methods. They are essentially fall under the category called high deformed simulation studies called explicit dynamic analysis domain. So you could see that that is why this slide I purposely put a finite element model. So one of our group students also have been working on looking at crash simulation using numerical methods. So you see that the vehicle is completely digitized and discretized in terms of elements and nodes with the placement of human dummies. There are family of virtual mathematical dummies with this kind of accelerometers or load cells and strain gauges all engaged with them, and then to find out the severity level, ultimately all lead to testing of efficacy of your restraint system in your vehicle. So this is that the advantage or highlights of ATDs. And then when you continue with that, these sensors do measure what are here for more detail. And essentially in head, we are looking at resultant acceleration and head injury criterion value, 3 milliseconds acceleration value, and so on. That goes up to for all these locations transducer measurements, interestingly. And these dummies are again, I call ATDs. Look at this special dummy. This dummy is used in side impacts. So these are the important sensors and the locations here for a side impact dummy. And it is a head CG accelerometers, spine accelerometers, the rib intrusion measurement transducer, and then abdominal forces to measure. Then public symptoms force. So public symptoms is a portion and a pelvis. So that again, what is that force that is experiencing? Then pelvis CG accelerometer. So these are very important locations that we require to see how a human would get a severity during side impact crash. That's why this dummy is called SID, side impact dummy 2. So the entire dummy family, if you look at it, is hybrid 2 family, hybrid 3 family, and so on. They are classified, and this is especially of side impact dummy. And this is something like that you have from our textbook. You can see for all injury criterion, the formulas, how they are quantified from the measured data. For a sample purpose, I just have put this head injury criterion and 3 millisecond acceleration level or resultant acceleration formulas. It's not new to you at the moment. You have already been seen, and I could see there are groups working on their crash studies. They have witnessed these formulas in their presentation. And if you look at the family, it is not one dummy that we are talking on. Like human, as we have a family, the dummies do have a family. There are many variants. That's what is we could see in our upcoming slides. So dummies are classified according to size, age, gender, and impact directions. So this is very important, impact directions. Right. So this is all easy to follow what we say. So adult male, female dummies are different sizes, and child dummies represent different ages. Some dummies are used to assess frontal collision protection. That's what impact direction with respect to the other dummies to evaluate the side impact collision. The most current frontal impact dummies have sufficient biofidelity. So this is what is very important. This is where our ancestor dummy Sierra Sam was inferior, but as a first baby of this family, he has done his wonderful contribution towards crash analysis and crash testings, and that is where the motivation for the people to develop such kind of human replicating dummies with biofidelity. So, however, the grandfather is the grandfather to be used to evaluate rear end collision protection. However, neither the current frontal nor the side impact dummies have necessary biofidelity measurements capacity or nor durability to evaluate other impact directions. So that means what there is scope for using or the development of dummies other than these two configurations. So the dummies today is existing are better for two testing configuration. One is frontal collision protection assessment configuration. Another one is side impact collision restraint system protection or efficacy assessment configuration. Other impact directions, you see that still the requirement of dummies in terms of biofidelity to completely get to replicate a real human inside the vehicle. So most often the test engineers use the mid-size adult male dummy for automotive restraint testing. It approximates the median height and weight of 50th percentile adult male population. So the dummy which is used hybrid 50th percentile male dummy was first born in 1976. And you see there are many of the varieties, and then his elder brother called a 95th percentile male dummy and 5th percentile female dummy to represent female population and so on. So this 50th, 95th, 5th percentile are 50th percentile means it is 50% of population below this. So it is a kind of an average accounting an adult population representing this. 95th percentile male means it is a big brother, and it has been accommodating 95% of population below a human community. So if you take 100 people and 95th percent like that is what is the meaning of this. When child dummies have median heights and weights of children of specific age group, they represent without regard to gender. So again, you can carefully look at the child dummies do not have a gender difference. The dummies to represent both boy child and girl child. So this is all something about this, and this is the first dummy that we are talking from the first word of the lecture, Sierra Sam, and 95th percentile adult. So this is 95th percentile adult male dummy developed by Sierra Engineering Company in 1949. Was first crash test dummy used in the domestic automobile industry for restraint system development. Of course, that has been used for an ejection of seat from US Air Force from higher altitude with the highest speed of 1,000 kilometers per hour when it goes when it falls. What would happen? So that aircraft emergency parachuting of soldiers, their injury levels to all assess. On this dummy was first developed, and then it was also been used mainly also for automotive crash testing. And these dummies mimicked human shape and weight of, and were quite durable. However, they lacked, this is an important one, lacked human-like stiffness, the important areas such as head, neck, thorax. So these are some of the demerits of the first baby. They also were not extensively instrumented to measure responses that could be associated with all pertinent injury concern. Current dummy have been designed to be biophilic in their impact responses and extremely instrumented. The following is a discussion that what we are going to look at in other slides are going to cover types of dummies, that is their evaluation of family, right from hybrid to 3 families, and there is something called the CRABI, infant dummies. What does that means? It is restraint. It is child restraint airbag interaction. In fact, infant dummies and side impact dummies, SID, and then they have Euroseed 1 and Bioseed are side 2. These are all some of the family groups names, and also something called Thor Euronorm dummies are there. THOR, that is the test human occupant restraint system dummies called. So look at big picture, the family to know. Hybrid 2 dummy families here on the left corner top. You can see the 2 unconstrained hybrid 2 50th percentile male dummies used as ballast in low speed collision test. These are those 2 guys. The hybrid 2 dummies family had two major deficiencies that limited their usefulness in assessing the efficacy of restraint systems. They lack human-like response stiffness and their heads, necks, thoraxes, and knees, and they were sparsely instrumented. So it is almost the similar version of the first child, and they are not that biophilic dummies. And then 1976, the next family group that is evolved, that's hybrid 3 dummy family, and they have been extensively used till date, hybrid 3. The 50th percentile male dummy, which made its first appearance in 1976 in the familiar crash test dummy. And he is now in a family, and now he is not a single man, he's a family man. So you could see here is he could stand upright. He would be 170 centimeter or 175 centimeter tall and would have a mass of 77 kg. He co-couples the driver's seat. So he occupies this driver's seats. All insurance institute of highway safety crash test conducted at this particular speed, an offset frontal crash test as well, right? And you can see here this Miss Hybrid 3, that's fifth percentile female dummy at diminutive. The dimension and the height of that is 152 centimeter, 5 feet, and 50 kgs. So you could see here this first family, his big brother, and he is the 50th percentile hybrid dummy, and then Miss Hybrid fifth percentile family dummy, and this is that family. Then you could see the hybrid three-child dummies represent a 10-year-old 21 kg, 6-year-old 15 kg, and 3-year-old dummies here. So these are the children of this family. The child model are very recent additions to the crash test dummy family, because to little hard data are available on the effects of accidents on children, and such data are very difficult to obtain. These models are based on large part of estimates and approximations. The primary benefits provided by hybrid 3 is improved neck response. So what is that advantage? Neck response. Look at in this neck is not resembling in the next family neck response in forward flexion and head rotation that better simulate the human. So continuing with this, you see there are other dummy families called CRAI, infant dummies. They born in 1990, second SAE task group of the Human Mechanical Simulation Subcommittee, converted to develop instrumented 6-month, 12-month, and 18-month-old infant dummies. The dummies would be used to assess the injury potential to infants during the interaction of deploying passenger airbags and rearward facing child restraint placed in the front seat of the vehicles. That's why these are called child restraint airbag interaction dummies. And side impact dummies, you could see that side impact dummies. So these are these dummies, what are CRABI dummies, and you could see side impact dummies are on the left bottom. There are 3 commercially available 50th percentile adult male side impact dummies. So SID, that's this one is what is called SID, and the middle one is what is called Eurosid 1, and this one is what is called Biosid. They are shown in this figure, 50th percentile adult male side impact dummies. You can also use 5th percentile female dummy hybrid 3 for a side impact test. So the side impact primarily given what the rib cage design. That's very important. So the rib cage displacement would exactly resemble same as that of how our ribs would be displacing in the event of compression load that's going into the human with the crash pulse that are acting on them. So what is essential is dummy harmonization. Like human harmony is what is essential for peace of world. This dummy harmonization is going to have a good hold on further development of vehicle safety systems, in particular, are in big domain where all you require human to be tested, and especially on aircraft crash and so on, which we cannot take a chance of even taking cadavers. Cadavers are very old techniques, and before Sierra Sam born, the test 1930s and all were conducted with cadavers. They would be embedded with some sensors, but the locations are dislocated. There are demerits, but of course that was the first attempt to do kind of measurements data for injury assessment with cadavers. So there have been replenishment now with this complete new family of ATDs. So we have many data on these dummies. I'm not going to go through in detail, and I just have stacked here so that it is ready reference for you to look at it. And see these tables here, key dimensions, weight of various size and dummies. So you have infant, child, adult, the dimensions and weights are there with the different orientation of dummy, and the weights of individual organs. of the dummy, right? So you may go through later, and it's also available in our textbook. And then you see chronology of notable dummies used by United States auto industry. You also have Euro dummies, and every country they have their own development. These are something the very first, and then they are giants in this. And let's look at the highlights of the um, biography of these dummies. So the first dummy is 1949. That is Sierra Sam. And then you can see the key feature of that, and then deficiencies, and are they currently used? So they are outdated. So you can see there are particularly in 2006 the expiry of this person Sierra Sam happened. That is an absolute time. After that, there's no more use of this. So, but this still 2006, it was somewhere also it's tested. But now current use of this is not there. So like that, you could see that after that, you see 1966, they are called a VIP series, very important people. 50th percentage female, 50th and 95th percentile male in frontal crash. And then again, Sierra Sierra Stan, Sam and Stan, and in frontal crash. So like that, you could see that it's been gradually evolved. And every year you could see 1 year or two also. And you see here, this is an important period. So till 1976 also, they are only hybrid 2 family. And 1976, where you had the first hybrid 3 dummy by General Motors developed for frontal and rear impacts. And they are worldwide now recognized or used. So the other dummies all stopped working even in they are not currently in use, and these hybrid 3 onwards only they are in use. And 1979, the side impact dummy was there. 1982, the child restraint airbag dummy was there. The passenger airbag test till it is being used. And you can see what are the kind of key features of every new version of the dummy. 1985, 1987, 1989, gradually it has come, we could notify this key features of them. And then 1989, 1990, you had again the revolution in this, but all are in a group called hybrid 3 dummies. And 1997, again, you see the child dummies where many for frontal and side impacts come, and side impact, the hybrid 350th percentile made side impact dummy, again here with the additional key features, and their utility is still there worldwide. And like that, if we go, we can have till date the many number of revisions and versions of dummies, and I have just put these data interesting that you will readily refer from our textbook. It is available in 7th chapter of the textbook, and title called Anthropomorphic Test Devices. And see that we have been looking at currently the dummies can be right from small infant dummy to test airbag restraint system till an adolescent dummy, a big brother dummy of 50th percentile or 95th percentile hybrid 3 dummies. And this all dummies development is go with the credit of Humanetics on the innovation solution. They're giant now. Though the first Sierra Sam is Sierra Engineering company in California, and today is the complete hold of this is monopoly company, Humanetics Innovative Solutions. And that's what is now we could see a big harmonized family. They are widely used across the globe for such kind of testing, right from infant to healthy, tall, strong 95th percentile male adult, male dummy, right in this picture. So this is all something that we should be aware of talking on. human dummy. So I'm just going to project some interesting videos on these dummies development. They are used in crash testings and so on, and we're going to end the lecture, right? So you have anything to ask at this point of time? If not, let's just go ahead with watching those interesting videos. So are you able to see this video? Yeah, I'll play.
Born in 1949, Sierra Sam was named after the Sierra Engineering Company who built him. Weighing in at 200 pounds, he stood upright at 5 feet 10 inches. Modeled on real pilots, his steel and rubber construction accurately mimicked the size and weight of U.S. Air Force aviators.
They were simply a dummy with movable joints, movable limbs. They were the right height and the right weight. So they may be dropped out of an airplane with a parachute, and the goal of the test was to see if the parachute opened and maybe see if there were any broken parts on the dummy.
While Sierra Sam made pilots' life safer, his use in the car industry was limited. His highlight reels did provide shocking evidence of what happens to a body thrown from a car. But his crudely jointed limbs meant he didn't sit in the car like we do. And his inaccurate weight distribution meant when the car crashed, he didn't act like a human occupant. This lack of human-like responses, coupled with little or no internal instrumentation, meant his so-called biofidelity was low.
Crash dummies need to be designed so they behave the way a human would behave. As an example, the ribs of a crash dummy are designed so they compress the same amount as a human rib cage would compress. The difference is the dummy's ribs are designed not to break. Instead, we measure injury risk from that crash test.
Although he didn't make the grade, Sierra Sam is considered the grandfather of all modern dummies. It's in his memory that they strive for the ultimate goal of perfect biofidelity.
So is it not interesting to watch this video? Yeah. So we could see our the first dummy here, and then let me just to see now what is that and latest the current family of human surrogates dummies and from Humatics company itself. So let's watch this another very interesting video of the current status of the dummy.
The humanetics of today has a lineage that stretches back more than 50 years into the early days of crash test technology. Beginning with the first true crash test dummy business founded by Mr. Samuel Alderson in 1952. Humanetics is the evolution of human surrogate technology from every era, automotive, aerospace and military crash testing, and more.
We supply the world, or we supply medical industries, we supply research industries, we supply aerospace. Anybody that needs to understand what happens to a human when they're put in harm's way in any kind of vehicle will talk to Humanetics and come and look at our products.
The goal of producing human surrogates is to build them as human-like as possible and therefore be more useful to those who rely on them. Producing crash test dummies that are increasingly more biofidelic has been the focus within this segment of the safety industry since its inception.
The most important thing that Humanetics does is really centered around saving lives. And they do that by making devices that can measure for possible injuries that can be prevented to save those lives.
The very nature of Humanetics products requires a high level of technical expertise with multiple disciplines working together to achieve desired results. This small niche of people is made up of a global community of safety experts, regulators, and researchers. The members of Humanetics have served many functions over the years within this tight-knit family. We're a culmination of expertise gleaned from decades of service to the safety industry.
You have to understand, the mechanical aspect of things and the biomechanics aspect of things, and to some degree even the computational end of things. So it's a really sort of a very specialized sort of field, and you have to be very good at a bunch of different areas.
Humanetics must design, manufacture, and test almost every product we sell. From 3D computer modeling to molding each and every flesh component of the physical product, Humanetics produces the tools that provide the answers customers need in designing the next generation of vehicle safety systems. Humanetics has the most extensive crash test dummy portfolio in the industry. Its product lines range from newborn infants to large-size adult surrogates that are used throughout a broad range of testing and research facilities. In addition, Humanetics designs and manufactures the force and moment sensing devices called load cells that can take the form of any bone or structural segment within the anatomy of the crash test dummy to accurately measure the potential injuries that can occur in a crash scenario. Humanetics is also the only crash test dummy supplier that provides support in maintenance, calibration, and training of all of our products to customers on or off-site worldwide.
We certify the dummy parts as well as do full dummy certifications in order to make sure the dummies pass regulations for use in vehicle testing.
By utilizing this combination of products and support, consumers can assure that they have the right foundation to get the best performance for their crash test environment.
Data is typically collected through a data acquisition system that's either mounted in the dummy or inside the vehicle or sled when the test is performed.
The physical world of vehicle testing has come a long way over the years, but vehicle manufacturers now have the ability to run computer-simulated tests to predict system performance, therefore saving cost and time. For that reason, Humanetics offers a variety of three-dimensional finite element models that mirror their physical counterparts. These complex models are actively maintained and updated regularly to reflect the latest technology as well as keeping pace with the rest of the industry.
We get a lot more information than you would get out of a normal crash test. So even a very high-end dummy may only have a few hundred sensors, where we have hundreds of thousands of points of data, and each one of those can give you a vast amount of information.
Humanetics' mission is to provide the most state-of-the-art crash test measurement devices and services in order to reduce injury to all occupants in any crash scenarios.
It has been found over the years that the fatality rates for vehicle crashes have either stayed steady and are now starting to decline, even though the number of vehicle miles driven every year increases. This means that the product that we make is very effective in saving lives.
This often lofty objective will continuously reduce the number of traffic fatalities and the cost of injury to all of society.
We're looking at the future of what safety could be, and we want to make things safer for people going forward in this industry. And that's a very exciting part of being a part of Humanetics.
Humanetics Innovative Solutions has placed itself as a forward-thinking company within the safety industry to greatly improve the consistency and repeatability of its products, which will ultimately save lives for years to come.
So wasn't that more interesting and informative video lecture that we have just seen? And then let's watch again some more interesting videos, how these dummies are under the crash test, right? Let's understand that now.
I'm Marvin Hatchett. I am the Dummy Calibration Lab Manager. My job is to ensure that all crash test dummies are calibrated and ready for testing. The general idea behind the calibration is to ensure that a dummy used at the Institute will react the same way as a dummy used in other test labs. It also gives us repeatability from test to test. The calibration test consists of head drops, thorax impacts, knee impacts, and also rear impacts. Here at the Institute, we have three types of dummies: frontal impact dummies, side impact dummies, and also rear impact dummies. We also have different sizes, ranging from a 6-month-old infant to a 95th percentile male. The 95th percentile male crash test dummy is larger than 95% of the population. I wouldn't have a back if I tried to pick him up. Our workhorse here at the VRC is the Hybrid 3 50 percentile male crash test dummy. He's 5'10" and his weight is 172 pounds. He is used in our frontal test programs. The test dummy that we use for rear impact testing is called BioRid. He has articulating vertebrae. He reacts very much like a human, and he's definitely more biofidelic for rear impact testing than the standard frontal impact dummy. This is our 5th percentile female. She is used for side impact testing. We have from 20 to 40 different sensors in the dummy. We have accelerometers, which measure the acceleration. We have load cells, which measure the forces. And we also have potentiometers in the ribs that measure the movement of the rib. Once fully instrumented, our crash test dummies are starting to approach $200,000 in value. It's fascinating that we can take the technology that we have and place it in a vehicle and send the vehicle into a barrier, and afterwards take that data given to us by a freshly calibrated dummy and use that data as one of the tools to determine what would happen to a human if he were sitting in the dummy's place.
So we just witnessed how these wonderful ATDs are used in actual real crash test. How do they get calibrated and nicely handled and employed inside the test vehicles, and involvement of data collection and so on that we have witnessed on this video. And let's look at again these dummies responses in two important critical scenarios of crash testing. One is the frontal offset all collection, and how important these data are captured. There's something called a high facility photographic technique that goes in high speed image cameras and so on. So under those cameras, how are these dummies are appearing, and how the dummies responses in kind of rear impact underride test, which we have not witnessed earlier. So these are the two more videos lectures for another few minutes, and then we will end our lecture. So let's look at now what are the significance of photography.
A crash happens in a fraction of a second, much too fast for a person to grasp with the naked eye. So in order to understand what's really happening in a crash test, we need to slow the action down significantly. And to do that, we have to rely on sophisticated photographic equipment, like special lights and high-speed video cameras. These are some of the tools we use at the VRC every day. I'm Penny Kalnight, and one of my responsibilities at the Institute is making sure that the photography we do is the very best of its kind. The VRC is more than a scientific laboratory. It's also a specialized production facility where we produce footage and pictures that engineers use in scientific analysis, and that we also use to communicate our findings to the general public. We designed this crash hall with high-quality photography in mind.
Lights! Lights!
In some respects, it's like a Hollywood soundstage with a very high ceiling and a grid that holds a custom-built lighting array that produces 750,000 watts of soft, diffused light. It's important that the light doesn't cast hard shadows and reflections, and it has to be very bright for our state-of-the-art digital imagers, or slow-motion cameras. These high-tech cameras are completely file-based, no film or tape, and they accept cinema-quality lenses. They can record in extreme slow motion, which makes it possible for our engineers to examine every detail of a crash. And because of the techniques we use, they produce very high-quality images that are suitable for television. Our technical photographers set them in a number of positions throughout the crash hall.
Go ahead and plumb bob, and then check height.
For each test, we have a set of predetermined positions for all of our digital imagers.
48,
We want to make sure we're getting the exact same shot that we got the last time we ran this test, so we can compare vehicle to vehicle if we need to, but it also makes sure that we're consistent with all the footage that we get.
With our digital imagers, we have a monitor attached here that allows me to adjust exposure, focus, and I can actually get a full readout on the monitor so I know all the settings for the test.
This is one of our small digital imagers, and we use these cameras on board during the crash. It's ruggedized, so it can take the impact of the crash. This one will be looking at the driver dummy to see how he interacts with the steering wheel, the airbags, and what's happening during the crash.
I just finished installing our overhead digital imager. This gives us a really nice top-down view of the impact.
We set up cameras in various locations so engineers can analyze the crash from multiple angles and so that we have the shots we need to tell the story. All of the digital imagers are connected on the same network and start recording at the exact same time. In addition to our slow motion cameras, we use a number of real-time cameras to convey a sense of how quickly a crash really happens, and a still camera to shoot a very high-resolution image of the moment of maximum crush.
This is our high-resolution still camera that we use to take the action shot of the crash test, as well as the post-crash photos.
After the test, we move the car to the photo studio where there's a large overhead light box and a fully programmable light control board, as well as a seamless background and a turntable that sits on air casters. That allows us to lift the car up and spin it to any position that we wish. We also have digital imagers and a lighting grid in the slit area, where we test vehicle components like seats and head restraints. The slow motion cameras capture the action, which occurs in a fraction of a second.
The last step for the footage is our post-production room, where it's color corrected and edited.
Once the raw data is loaded onto our file servers, I can access that information and translate it into video that accurately represents what the eye sees. Then I edit that footage into various video products.
The images we produce are more than just tools to help engineers understand what happens in a crash test. They're also a vital part of our communications effort.
The new crash test results we have for you tonight are raising...
Photos and footage produced at the VRC have appeared in countless news and television programs, automotive advertisements, and even Hollywood motion pictures. The Institute is respected worldwide for the excellence of our scientific research, and we're widely known for our consumer information and our vehicle ratings. One reason for this is we're able to provide high-quality images and footage to the media and the public to help illustrate our findings, and this extends the reach and the impact of our work.
See how awesome that video, what a coordination that was there involved with the people, and then the post editing and then compiling the entire test scenario digitally. So tremendous coordination and patience that is what that could witness, and then involvement what we see that. So how nicely they are preparing their environment before conduct of the test, and how powerful lighting and visual capturing aids, cameras, and so on. And they're importantly, where are they located in the with reference to the vehicle under testing with the barriers. So much information, informative video just in 4 minutes that we are going to get. So I feel always to watch this again and again, so that we'll always be remembering so quickly we can get the grasp of the cracks. So that's what the reason I wanted to play this video. And finally, we look at one more video, and that video is in action for under-ride simulation of crash testing.
My name is Matt Brumbelow. I'm one of the research engineers here at the Insurance Institute. A few years ago, we did a study of frontal crashes in vehicles that had a good rating in our frontal crash test, and how people in those vehicles who were belted and had airbag deployments were still being injured or killed. And a lot of those crashes that we found were into the backs of large trucks. We wanted to look more closely at those and see what could be done to try and make those crashes more survivable. And there is a federal regulation for the guards that have to be put on the rears of large trailers, but it turns out that regulation is not working well to prevent underride crashes. As we thought about ways that we might be able to improve the situation, we thought that it would make sense to compare how different designs do in the exact same crash conditions. So we took trailers from the 8 largest manufacturers by sales volume in the US, and we tested each of those trailers in 3 different conditions, all at 35 miles an hour. By doing this, we're able to show that some guards already perform much better than others. We've conducted all of these trailer underride tests with the same passenger vehicle. It's a 2010 Chevy Malibu, and we chose it just because it is a typical mid-sized sedan and because it's a good performer in frontal crash tests at this speed. What we really wanted to highlight is that it's the trailer design that needs to be improved and changed, not the passenger vehicle design.
I'm Sean O'Malley, Senior Test Coordinator at the Insurance Institute for Highway Safety. For this test, we've purchased 8 brand new semi-trailers. We will first put it in position in the crash hall, take measurements of each component of the back of the trailer, the frame rails, underride guard, the door opening. Then we will load the trailer with 38,000 pounds of concrete blocks. We've tested them at a full width where a car hits the center of the trailer at 35 miles an hour. We then tested 50% overlap where only half of the car hits the trailer, and then again we ran it at 30% overlap. Post-crash, we will measure the trailer again. With these measurements, we determine how far things have bent and moved. After this test, we will remove the car from the trailer and place it in photo studio. In the studio, we will do a detailed analysis to determine dummy contact points inside the vehicle before we measure the door and window openings to determine how far the trailer intruded into the vehicle.
Manufacturers have been really receptive, by and large, to the testing that we've been doing. Most of them have never been able to see how their guards would perform in a crash test. What we're hoping is that as they get their results and go back and compare how they've done relative to their competitors, that they might be able to make improvements just on their own initiative. But in the long run, there's a chance that the regulation could even be rewritten to require a lot of these improvements.
So wasn't very interesting underride crash test of a passenger vehicle under a heavy vehicle, and the significance of measurements and data collection that we have witnessed in this test as well. Like we have watched many crash videos in frontal collision or different test configuration for that matter. So this is how you see when you say crashworthiness of vehicle, and that's the first word, but see how much scientific research and science behind and the regulations behind. So today we are comfortably on our vehicles with full safety assurances, all because of such kind of scientific development. So I'm very happy that at this moment that concluding our course MEE6025 vehicle crashworthiness, I made a big attempt to gather the information. It's kind of, you have like watched videos, many videos. So I have watched many of the videos, and I was very selective to organize them to show you during my lecture hours. A few of the lectures we had only video crash videos to witness, to understand quickly more information, and then more of informations were organized on a PowerPoint, and then I used these boards to explain you mostly of the fundamental mathematical calculations that go in when you say crash assessment and so on is concerned. So though we are unable to meet in classroom and learn this course, this online platform really helped to have a very comprehensive, consolidated, very informative lecture to deliver. With that sense of satisfaction, I would like to conclude this lecture on the course. So if you have anything in particular to ask, you may please listen back to those lecture videos available to you and post comments on that. and I would be happy to respond to those comments. So with that note, I would end today's lecture and the course as well. Thank you for good learning with me. Hope we will have good time in your assessment in examination and so on. And some of you are excited, and in future you are pursuing your career as a crash test engineer, and then you are working in humanities or in some of the agencies, or you are in Bharat Automotive Safety Assessment programs. I'm very happy. The task with which I have started teaching this course would realize on that day the sense of happiness. So with that note, I would end the lecture and the class, right? Thank you.